First of all, thank you very much to Douglas. Thank you very much to the Durham Energy Institute as well for giving me the opportunity to speak today. My name is Charanjeet Singh. I am a Senior Strategic Opportunities Manager at CPI. I think Neil mentioned a little bit about CPI earlier, but I'll cover that maybe a bit later if you've got time. So my focus for today is to look at the opportunities to do with battery materials. So I have to thank Karen for giving a good overview on the science and the technology behind that. So the plan today wasn't to talk about the science, but more in terms of the opportunity related with these materials. So don't want to dwell in this too much, but I think everybody recognizes there is a big problem in terms of greenhouse gas emissions and its impact on the climate itself. But I think all I was trying to draw attention to is, at least in relation to the UK, the biggest emitter related to greenhouse gas emissions is related to transport. And if you break down transport further, what you find is, a big proportion of the emissions are actually coming from passenger cars itself. Of course, there are, the other emitters as well in terms of heavy ground vehicles and so on and so forth. But I just wanted to very quickly do a recap on that. And I think, there's some fantastic talks this afternoon and this morning as well. And I think here, all I wanted to sort of draw people's attention to was, I think the UK fully understands its commitments in terms of addressing climate change. And therefore, it's on a journey at the moment to try to achieve net zero emissions by 2050. So one way of doing that is then having a number of frameworks, regulations, policies in place. And the whole ambition here is, how do we try to decarbonize all the different sectors in order to achieve net zero by that specific time? And I think what we also find is that, this target, sometimes the dates keep changing. So we do find that, the science indicates there's a higher urgency. So these dates might change actually going forward. Now, so this then translates into policy for the other sectors. So in terms of transport, by 2050, the target there is that all transport sectors have to be decarbonized by then. And then, it sort of trickles down further in terms of if it's transport, if it's to do with passenger cars, how does that happen? So we have what we call as the Road to Zero plan. And that is where I think the ambition is to ban the sale of new petrol and diesel or even hybrid vehicles in the UK by 2030. So that's in the next 10 years or so. So how do we achieve that? Or how do we replace what we call as internal combustion engines? So a lot of it is currently based on electrification. So, there's discussions about whether it's fuel cells, is it looking at battery technologies, and there's benefits apart from electrification in terms of, as for example, internal combustion engines, in particular diesels, you have a lot of particulates, which are also harmful in terms of health and also, in terms of the environment itself. So please, I think my talk is, as what you said earlier, I think we want to focus more in terms of, I think here, I'm going to be speaking more in terms of the passenger vehicles itself. So here, I think all I was trying to convey the message here is, if you look at the top left-hand graph, we have, I would say, an acceleration in terms of EV adoption. And this is a global figure up to 2019. And you can actually see it's a rapid increase. And I think a lot of the market predictions are it's just going to accelerate in the next few years or so. The bottom left graph essentially is talking about the UK market specifically. And even though the figures don't look significantly high, it's projected to grow significantly in the next, say 5-10 years. We've got this deadline of by 2030 where you can't sell any more internal combustion engines. And I believe the total figures of cars being sold in the UK every year is like 1.2, 1.3 million cars or so. I might have the figures slightly wrong, but we're talking about significant numbers actually. On the right-hand side, I think this is just a prediction from Bloomberg itself. So it's talking about adoption globally. So, more than half the cars would be based on electric vehicles by 2040 or so. And we're talking about 60 or 70 million cars by then. The other thing I think I just wanted to make people aware is that there is specific regulations that are driving the automotive sector. And in particular, if you look at the graph on the right here, these are targets set by the European Commission. So this is, I think, even before the whole net zero concept was coming along in terms of, there's a rapid acceleration to how do we cut emissions. So these figures here essentially forces the auto manufacturers to develop technologies which will ultimately achieve emission targets, for example. And if you fail to achieve these targets, they are typically fined. So, companies like Tesla do get credits, for example, because they have clean technologies, if that makes sense. The other implication is, if these targets are coming along at very specific timelines, the automakers then have to plan and say, all right, if you're going to sell cars for 10 years, and if we need to design and develop a car for another 4 years, what do we plan for future cars which are coming in 2025, 2030 or so? So a lot of the decisions that these companies need to make are already being made today, or they have to be made going forward. I think that's the message I wanted to pass on. And you might have already noticed there are a number of new electric vehicle cars already on the market, but I think it's just ever increasing. I think you noticed that quite recently also as well. I just put a couple of examples. People are aware of the Nissan Leaf because it's produced in Sunderland, and I guess people are also aware of the Tesla, which is very popular as well. But this was just a snapshot. So it's sort of just talking about what I described earlier, that the automotive sector is responding to the need in terms of both the consumer need and also in terms of the regulatory need as well. And this, just a snapshot. It wasn't trying to promote specific brands or whatever it is. We're talking about major car companies, Volkswagen spending 60, 70 billion. We've got Jaguar Land Rover. I think we've heard about Tesla investing in Europe. I think they've invested in China. So a lot of these auto manufacturers are now starting to look at how do we shift away from internal combustion engines to electric vehicles. And there's a big shift there. So it's not only looking at the battery technology, it's looking at the powertrain and a variety of different things as well. I think a lot of maybe the audience would recognize this. There are some challenges related to electric vehicles, and I think Karen touched on this earlier as well. A big proportion of the cost of these vehicles are related to the batteries, so it's related to the cost itself. How do we reduce the cost of these battery packs, for example? There's also a big concern in terms of range, although I think that's being addressed more and more recently as well. So there's always this range anxiety in terms of, can I buy a vehicle which is going to take me, for example, to Cornwall, that, I don't need to, for example, charge it midway, for example. And I think another key point is in terms of, do we have the necessary infrastructure for charging? And also in terms of charging time, do you really have to spend 6 or 7 hours to charge up your battery? Or if you could do it, for example, within 5 or 10 minutes, would that actually make a big change in terms of the consumer perception and demand as well? This next slide, actually, I think all I wanted to pass on to the audience was, and I think some of the speakers today have spoken about this earlier as well. It's fairly a complex process to make one of these batteries as well. So it starts all the way from mining. So I think there was a nice talk this morning from the British Geological Society. I think they were talking all the things related to rare earth materials. So, step one is, do we have the necessary raw materials, the cobalt, the manganese, the nickel, and so on? And typically that's mined, and in some cases, or most cases, I think it's done overseas. So there's some, I would say there's some limited production in the UK. How do you then take those materials, those salts, and then convert it to what we call as electrode materials. Those electrode materials, then you have to combine them with a variety of different components. You have binder systems, conductive carbons, and that's typically deposited onto current collectors. I don't want to go into the science too much. I'm not an expert myself personally, but I think all I was trying to say is, these then are assembled together to form what we call as a cell. And you have to have multiple cells within a module, including some of the electronics. I think here this is referring to the battery management system before it actually goes into a vehicle. And I think one of the concepts I also wanted to say is, like, we shouldn't look at this as I would say, sorry, I think all I'm trying to say is we have to look at it in a circular fashion, so that at the end of the life of that battery, we should look at how can we recycle some of those materials and then, use them as raw materials for their subsequent use as well. Okay. So I think this was just to give an overview of where a lot of the production is currently done for batteries. As I think people are not surprised maybe to see this, about 90% of it is done currently in Asia. That's where I think a lot of the manufacturing to date has been done. I think some of the earlier speakers talked about China for solar panels as well. So it's not too dissimilar. A lot of the raw materials are based in most of these countries as well, including Australia and so forth. There's some production in the US. We've known about Tesla for many years now, and there's also production in Europe, although I would say it's limited. Graph on the right is just talking that there's a big demand for these electric vehicles, that a lot of companies are now thinking of setting up manufacturing in Europe as well. So it's just talking about the various different companies who have announced their plans to expand manufacturing in both Europe and also in the UK as well. I just wanted to give an example because I think this is a sort of like a north of England talk. So there is a company, a gigafactory, who actually produces batteries. Not too far from here, it's in Sunderland. So they're called Envision AESE, and they've been supplying the battery packs that go into the Nissan Leaf. So they have a current capacity of about 1.7 gigawatt hours per year. I don't want to dwell on this too much, but it's just talking about the various different technologies they are starting to look at. Karen touched on this earlier. It's primarily looking at lithium-ion batteries, rechargeable batteries. I think solid-state batteries is something that is coming along maybe in, I don't know, next 5-10 years or so, not immediately. And then I think I just wanted to make people aware. There was a recent announcement that there's going to be another gigafactory in Blight as well. And we're talking about huge sums of money being invested. But it's also fair to I think to remember that this sort of gigafactories are going to employ thousands of employees, and there's a trickle-down effect as well. So they would require materials that go into their factories. So there's a multiplier effect. So even though it sounds like 3 billion is big, the multiplier down the supply chain actually is going to be significantly huge as well. Just move on to the next slide. I don't want to take up too much of time. Here, I think I just wanted to make people aware that there have been some studies done by both the APC, the Advanced Propulsion Center, Faraday Institution as well, where they have they've sort of done a study in terms of what sort of capacity is required going forward. So I think this was assuming that all production of internal combustion engines will diminish over time, and electric vehicles will be the way forward. So we're talking about a fairly big figure per annum, 140 gigawatts or so by 2040. As we talked about, a lot of jobs will be required. So there'll be a whole piece in terms of upskilling, because we are talking about a different technology from combustion engines itself. And I think Karen talked about this earlier as well. So we are talking about the materials that go into this battery, to these cells. And I think that's been modeled or to be calculated to be about 2 or 3 billion pounds per year by 2030. And what's important to know is that most of the value within a lot of the cells are associated with the materials. So more than half of it is actually, the value that the materials bring to it. This graph on the bottom right might be a little bit difficult to see, but it was just breaking down the different components of these materials and what their values were in relation to the cell. And that basically comes up to that figure of 56%. The largest figure typically is associated with the cathode materials, anode materials, electrolytes, etc. Move on to the next slide. So I just wanted to sort of do a very quick summary in terms of what the challenges are in terms of supplying some of these materials. And I think Karen touched on this earlier. So it's looking at cost. How can we reduce costs associated with these materials? How do we look at increasing some of the performance of these materials related to density, for example, energy density and power density? And this actually relates to how do we improve the range, or how can we enable faster charging, for example? How can we improve some of the performance of these materials, reliability of these materials, or the cycle of these materials, so that we can extend how long we can actually use these batteries, so that we don't have to keep changing them every so often. There's this whole element of recyclability, which has become more and more, I think, important recently. I think previously maybe we haven't fully considered elements of, for example, design. How can we design things which are easier to disassemble, easier to recycle, for example, or develop materials which are easier to recycle as well. And of course, a lot of this is, one of the most important things is related to safety. How do we develop materials which are safe as well, that consumers are comfortable in terms of using them as well? Just before, I think this is my last slide, Douglas, but I think all I wanted to show here was I started looking at mapping some of the companies related to this area in the UK, and there's a significant presence of companies in the Northeast working in this area as well. So I think all I wanted to pass on the knowledge was that there's a big opportunity I see coming in the next few years. There's a big demand in terms of, we know gigafactories are being set up, and therefore they need supply of materials which go into their factories. There's a whole piece which I didn't talk about in terms of the implications of Brexit in terms of exporting to Europe, where a bigger proportion of products being sold into Europe have to be manufactured in the UK. So there's what they call as the rules of origin come into play. I think with that last slide, I think I'd like to stop there, Douglas, if you don't mind. I'll skip this part, but it was just a quick intro on CPI, actually. But yeah, thank you.
Okay, that's great. Thanks very much, Charanjeet.